Hey everybody. Been going on about common tool sets for a while now. The last video I posted was focusing on solid carbide end mills. Today I'm going to branch out, start talking about face mills and all of the questions to ask as you select the common tooling for your shop so that you can standardize tooling across the machines, reduce your changeover times, reduce your programming times, and make more money. Let's go. Now, for the purposes of this video, I am going to be using the Sandvik Coremont website. I'm honestly a huge fan of consolidating your tools. You can save money and keep availability for screws and seats. You're also consolidating to one company to work with for recommendations. The benefit being there that when you're working with that one point of contact, they're more aware of your overall operations and they're able to better support you by understanding what your shop floor atmosphere needs. The other side is as well the customer service and the tooling support that I've received from Sandvik has been above all the other brands. Now, that could be a local bias. It could just be an indication of their global domination and their commitment to serving manufacturers. Whatever it is, it's not like I've done a bunch of peer-reviewed scientific studies. So you may want to stop watching at this point, but this is totally based off of the experience I've had personally in my own career as a journeyman machinist, as well as my time working on the consulting side of manufacturing. So all in all, it's about 2 decades worth of cutting tool experience. Now that you've got the disclaimer out of the way, let's dig in, and I'm going to go over some of the questions to ask, look at some of the dimensions, talk about some of the cutters from Sandvik. You can cross this over to whatever brand your loyalties lie with. I really look at it as like a good car maintenance video. It's not specific to any one brand. The principles are the same. The specifics are going to be different depending on the tooling that you work with. That being said, let's switch over here. Right when you come into the site, to follow along with me on this video, if you so desire, maybe you got your video on the phone and you've got your laptop or vice versa. Although I do recommend using their website on a desktop just because there's more searching functionality. If you've got an iPad, a tablet, something like that works fine too. So if you're following along with the video, I came here. I'm logged in just because I have an account with them. Now I've gone down to tools, milling tools, face milling tools, and then you can see the bevy of options that Sandvik has. Now that's one other benefit of choosing a top tier supplier like Sandvik to work with, is they're going to have a lot of options, which translates to a lot of geometry and solutions for you. The first step when you're selecting a face mill is what do you want for the corner prep, right? For the all-rounders, honestly, the 2-inch size, whether you're on a smaller vertical mill like a Haas TM1P or something, or you're on a monster, a 2-inch face mill is really quite flexible. It can get a lot done. It takes a little bit longer for those big surfaces, but this is going to be a factor of your average part size. For a face mill, as you're selecting, you're going to want to consider things like any radiuses, surfaces, as well as your work envelope. So even when I've been putting massive parts on, say, a VF6 or a VF8 table, and the part's almost taking up the table, I really want to be able to get my face mill down to the working height that I'm at to feed onto the part. And having a large diameter cutter presents obstacles for your tool changer, which you need to know if you can flag on your machine, by the way. But it also prevents obstacles for the way that you approach the part, right? If you've got a massive 6-inch cutter, then you've got to approach like 3+ inches off the side so you can get your room to approach. It means your work envelope is reduced by the radius plus about 10% of whatever your face mill cutter is. If you do a lot of big facing and you're on a big Lucas, or it starts with a K. I'll have to pop it up here somewhere. I'm dropping the name right now. But you know, one of the bigger programmable CNCs, and you just like having a big face, this is when you start to decide. You want to decide on the diameter. That's going to be your first step. Next, after that, you're going to want to decide on the style. And this is predominantly going to be determined by the materials you work with, by the type of finish you're looking for, and also by if you want to be able to use this for making 90-degree shoulders, or if you just want to be able to face off, right? And when you're making that decision between being able to do 90-degree shoulders or being able to face, the determining factor for what's always in your machine is going to be your capacity in your tool changer. And also how many pockets you want to sacrifice if you do decide to go to a bigger face mill. So the reason that this comes in is like a 2-inch mill on most machines does not require being flagged as oversized. A 2-inch mill with a 90-degree shoulder can be used for larger pockets, can also be used for bores, can be used for outside profiling edges, can also be used for facing. The goal with using common tools and setting up those sets that you know you can rely on is to have the most versatile options in your machine, and then have that 10% is flex for the specialty tools. So if you don't often do a ton of facing, dedicating a couple slots so you can have that big dedicated facer in your machine at all times doesn't make a lot of sense. However, if you're in a job shop where you do tons of big plate work and counterbalance work and all these big constructs that you're constantly doing a large volume of facing on, then it may make total sense to have a dedicated spot instead of just putting it in every once in a while for the parts you need or desire to have the larger facer on. All right, so we've talked about diameter. Okay, so when we're looking at our options, you've got the 245, right? Light cutting, positive, 4 corners per index. Then you've got the 345. This is for your high feed. You've got the 745, which I'll put a link. I did a little bit of a preview of this face mill already. Fantastic choice. 14 index positions. If this works for your dedicated facing, this is the one to go to keep the cost down and the feed high. Don't want to spend a lot of time on this, but basically it's got the same cutting geometry as the 245, except it's a 14 position index instead of a 4. Then you've got your 365, right? 8 cutting edges now, roughing to semi-finishing, mostly in cast iron. Then you've got the 425. If you're going to be finishing a lot of cast iron, you get 8 cutting edges again, high precision adjustment for all the individual seats. You've got the Century mills, which are lightweight, high RPM. These leave fantastic finishes in aluminum. If you do a lot of aluminum facing, I recommend you look at the Coro mill Century cutter. And then you've got the 360, again, for larger facing, still only a 4-position index. But when you're looking at replaceable cartridges, it does make replacement of the tool over time and maintenance much cheaper. And then you've got your 490, similar to the 390, but not to be confused because they do have a square cutting geometry. They do have a little more carbide, but they do provide that 90-degree wall. Then you have the Coromel 331, which is slitting through coolant, everything else. Then you've got the high feed 210, and then you've got button mills, and then you've got the S60. So as you can see, even here, right, we've talked about, what geometry do you need? We've talked about the size and the benefits of dedicating a pocket to all of this. But then you start looking at all of the different options here. Now, one, if you're familiar, then there's no big deal. This is pretty easy peasy. If it was me and it was me looking at picking the common tools, a lot of the time, if I'm doing high abrasion resistance, I'll go to something like a Coromel 200. And I will also throw in either a 490 or a 390. The diameter range is going to depend that. For the 2-inch, I would be going for a 490, and the 200 have a 2-inch in both of those. Honestly, because I've done a lot of funky profile roughing with the Coromel 200 and finishing. I actually ran 2 of them for a couple jobs. So I would run one to rough and one to finish because I could use the 2-inch diameter to rough the outside of the part. And we had some funky facing geometry. So we just had, what was it, like a 100 thou step down for the roughing and then a 20 thou step down for the finishing. And it was good enough surface because of the way that the rads work. But as you start to look at this, there are quite a few options. Now, thankfully, with the Sandvik site, you get tons of information. You also have their network. So they've got a how to use section. And this is going to break you through, finishing with wipers, heavy duty face milling, more removal, faster. So as you're looking here, you can see there's a lot of options. You can get really, really complicated pretty quickly. There's no need to make it complicated, to be completely honest. It's all just looking at your application and what's going through. Start with your material because, as you've seen here, some of these are more specialized towards die cast, some are more specialized towards aluminum, and some are all-arounders, and then some are more specialized for straight face peeling. I mean, look at the Cormel S60 or the Cormel 360. These are high metal removal rate tools. If you do a lot of flame cut steel, the 210 series right here, if you look at that angle, right? If you look at the angle here, I have shops that do a lot of flame cut profiles and flame cut steel. And so they run these not in climb milling, but in conventional because they actually get underneath the edge of the material. That's something to consider. If you do a lot of flame cut, I would recommend you look at the 410. Then, of course, you've got the 345. Honestly, I haven't really used the 345. I've used the 245 for a lot. The benefit here being the wiper inserts for that higher surface finish. And a lot of it's going to depend on the cutter range that you need. So knowing the manufacturer that you're working with to select this is going to give you a good idea of what's available in what ranges. And this is a perfect time to partner up with people in your supply chain to really talk with them about what's going on, what your plans are. In the end, when it comes to the whole supply chain, everyone really just wants to see each other succeed. When I'm working with companies, I am their biggest cheerleader because there's nothing that makes me happier than watching them succeed at what they do, being able to share that love, being able to make their days easier, whatever it looks like. So when it comes to sitting down to go over this, to help companies work through all the different questions, it really becomes a no-brainer. But getting off the soapbox, a little bit distracted there. It really just comes down to those questions. How big can you go in your machine before you start sacrificing other tool pots? It's part of the calculation. The goal here is to have common tools in the machine so that as you're programming, especially in that that job shop environment or the small run, high changeover OEM distributors, whatever you're doing, you want to be able to have a rock solid tool set because there's a certain loss when it comes to specializing. If you're changing over all the tools and you're constantly programming from scratch and you're spending all of this other time, you're really spending a lot of time to not really regain a lot of time. You have more tools you have to stock. You have a lot more around that versus having a common set in your mills where you have a couple extra special tools. You then have the same tool numbers, 1 through 10, say, out of a 20 pocket machine, are all the same across every mill in your shop. That makes setup a lot more standardized. It makes everything easier for the workforce. As we know, the skill level is all over the place in manufacturing. And it's really looking at the systems and the procedures and whatever you can do to speed up the onboarding of new hires. Because I can tell you, as a machinist that's worked on the shop floor, we appreciate the systems that are created to support us makes it easier to start at a new company when everything's laid out and you don't have to guess or refigure everything out on every single machine. So to recap, you're going to want to have an idea of whatever the max tool size is that you can fit in the carousel in your machine. You're going to want to have an idea of the size of the components that you have, because the size of the components is going to determine what size makes sense to dedicate in there. Again, over the last 20 years, I've seen a big leaning towards that 2-inch size. I've seen like 2.5 up to 3 occasionally. I've seen down to 1.5 inches when it comes to dedicated facers or profilers. But that 2-inch range really seems to be the sweet spot. And then you're going to want to look to see if it's worth dedicating a single slot or possibly 3 slots if it's an oversized tool for your carousel to have that dedicated facer on there. And it's going to be the volume of facing that you have to do. Some extra tips that I dropped throughout this video in case you missed them: doubling up on the high use tools like the Core Mill 200 button mill or a 390 or a 490 cutter, so that you can simply change tools. The next one's running while you change the inserts and clean the tool. Can really keep, well, it helps you keep the spindle turning and earning, right? My whole focus in the last 2 decades has been anything I can do to keep that spindle turning and earning is where I'm going to put my efforts, because that's what makes a difference on your bottom line. And knowing the questions to ask and the variables to verify makes all the difference in the world. So until next time, I do hope you're able to implement some of these tips so that you can keep your spindle turning and earning.